the game today is sequences, the goals. Number one, we want to find a formula for the nth term of a given sequence. And number two, we want to find the limit of a sequence. What the heck is a sequence? Well, there's kind of two ways to think about it. The more sophisticated definition is that a sequence is a function with domain the natural numbers. So you think of it as a formula for the most part, if you can find a formula for it. So in terms of this definition, here's a sequence. F of n equals, say, n squared. So, I mean, that's a function, right? So how does it differ from f of x equals x squared? Your inputs, what are you allowed to input? When it says the domain is the natural numbers, that affects what you're allowed to input in for n. So what are you allowed to plug in? What are the natural numbers? The ones you count with, right? So 1, 2, you're allowed to plug in 1, 2, 3, 4. So there's an order to this function that other functions might not have. So we actually usually use, instead of the function notation, we usually use a subscript notation. For instance, it doesn't have to be a, but we often use a sub n. But it has the same meaning as the function notation. So if you're finding f1, well, you would denote that by a subscript 1. Same thing. And so the subscript tells you the input. So for an input of 1, the output a1 is equal to 1. So you guys tell me, what would a2 equal? Plug and chug, what do you get?
4.
Easiest thing you're going to do all day, 4. And you can actually list the outputs in order if you put the inputs, the natural numbers, in order. And so the outputs, well, two, that you know the first output is 1, the second output is 4. So 1, 4, what's the next output? 9, the next one? 16, okay, and then on and on and on. And so the less sophisticated definition of a sequence of numbers that you may be more familiar with is just a listing of the outputs. So, you know, A1, A2, A3, A4, so on and so forth. Okay. So you've seen that before. Let's talk about the Sequence Hall of Fame. So in the Sequence Hall of Fame, let's go ahead and find that n. We're going to call that a sub n. So f, instead of using fn, we're using an to represent a generic output. And we're going to call that, whatever formula represents an, we're going to call that the nth term formula. So let's find a formula for the nth term of the given sequence. And all of these are in what I would call the Sequence Hall of Fame. It's probably located in Ohio, right? That's where the Baseball Hall of Fame is, and I think Football Hall of Fame. So the Sequence Hall of Fame, find a formula for the nth term of the sequence. Okay, part A, 1, 2, 3, 4, 5. Oh, the natural numbers, right? But what's the formula? an equals, well, the input equals the output, right? So an equals n. There you go. It is a sequence of numbers, right? It's kind of, you could also think of it as the identity sequence, I suppose. You plug in, the subscript is what you plug in. The guy here on the right is what comes out. So it's analogous to saying f of x equals x, right? Except you're only allowed to plug in natural numbers into this formula. Okay, so that's the first guy in the Hall of Fame. Part B, 2, 4, 6, 8. Who do we appreciate? Mr. Chamberlain? Mr. Chamberlain? No, nobody ever says that. 2, 4, 6, 8. So what kind of numbers are those? Even. And how do we generate them? What would the formula be? The nth term formula, an, what would that be?
2n.
2 times n. 2 times the input, right? Well, if the odd numbers, I blew it. Well, if the even numbers are in there, what else should be in the Hall of Fame? The odd numbers, yeah. So part C, 1, 3, 5, 7, the odd numbers in the sequence Hall of Fame. Okay, what's the formula? No, because if you plug in 1, you'd get 2, right? Yeah. So you can often check. I'm glad you may not be glad you made that mistake, but I am glad you made it. I'm glad not you made it, but somebody made it. Because you bring up a good point. You can check a lot of your answers when you're finding a formula for the nth term of a sequence just by plugging in a few numbers. So this one's not as easy. Any ideas? Well, yeah.
Could we use 2n minus 1?
Yeah. Yeah. So the even numbers, and you generate the even numbers, and you subtract 1 from each even number, you get all the odd numbers, don't you? So an equals 2n minus 1 would, assuming n starts at 1, that would generate, for successive inputs, 1, 2, 3, 4, that would generate outputs 1, 3, 5, and you'd get all the odd numbers.